Greetings and welcome to my new calculus channel. I'm John Gabriel, and today I'm going to continue with Euclid's elements. In particular, I'm going to be covering propositions 23 through to 37. So, let's begin. Now, there's nothing really remarkable about proposition 23 and 24, because what these say is that similar segments. So first of all, what are similar segments? Similar segments are those segments with an equal angle that is subtended on both, right? So we would say that this red segment is similar to the blue one if, when we move the blue circle center over there and rotated that, then it turns out that this segment is similar to this one. But what does it mean here when it says they cannot be constructed on the same side? Well, they can be constructed on the same side, but I think maybe what was meant there is that they can't be constructed on the same equal straight line, okay? And of course, similar segments of circles on equal straight lines are equal to one another. So that's pretty obvious. I mean, it doesn't matter what we do here. If we change these things like that again and move this through here, do you see that? Those are similar segments. Okay, and there's nothing really remarkable. This gets covered in my prologue, as well as right angles and parallel lines and the sum of angles in a triangle. All that is covered in my prologue. So now the next proposition, 25, says that for any given segment of a circle, to complete the circle is very easy. And this, again, is not a very remarkable proposition. In fact, it's unremarkable, but I'll show you how it can be done. So if this is the given segment, step 1 says we have to divide this line into 2, which is very easy to do. Step 2 says we have to draw a perpendicular at that point. And then we have a point on the arc, or the segment. I'm saying arc because I know it's going to be part of a circle. Step 3 says we need to join this point to the end point of the secant or the chord. Step 4 says we need to construct this very same blue angle at this location, at this point with this line at this location. That's very easy to do also. Step 5 says where these two lines meet is the circle center. And step 6 means we can complete the circle. Okay, so that's all there is to that one. Then proposition 26 through to 30 are all established in my prologue, and they're a result of the symmetry of the circle. Okay, and you can do those, check those out in the elements yourself. They're not that remarkable. Proposition 31 is quite packed because, first of all, it gives you a cyclic quadrilateral and tells you that that the angle in the semicircle is 90 degrees, and that's very easy to prove. Okay, and then you also have to prove that the opposite angles, so of a cyclic quadrilateral, like this angle here and that angle there, are supplementary, and there are two ways to do it. There is this way, with the quadrilateral passing through the center, which is very easy, and you can sit and study that in your own time. And there's another way where the circle center is not in the quadrilateral, and the explanation is given over here. I'm not going to spend time going over it. And so finally, you can show that the exterior angle, this red angle here, is equal to the opposite interior angle, okay, of the cyclic quadrilateral. And that's pretty much proposition 31. And 32 says that the angle between a tangent and a chord, like say for example this red angle, is equal to the angle subtended on this arc or this chord, okay, which is part of the angle. And the proof is very easy. We simply say that angle FBA, this whole angle here, is a right angle because it's given. And then we say that the red angle plus angle ABD plus this little part here is equal to 90 degrees because we know D is an angle in a semicircle, right? And then finally we have that FBD, and ABD, this little part here is 90 degrees. Okay? And then finally we can conclude that angle A is equal to this angle by transitivity of equality, okay? Because if you look at both these statements here, the only difference is angle A and FBD. All right. So the last part was proposition 33 to 37. They're all unremarkable and very easy to prove, so I'm not going to spend time on them. And that basically brings us to the conclusion of the first 3 books of Euclid. I've just given you the important propositions. And so the next book we'll be looking at is book 4. Also not such a great book, but in book 4 we'll try and cover only the propositions again that are remarkable and that are useful. And then we'll be going on to the very interesting book on magnitudes, which is book 5, where the theory of arithmetic is established on magnitudes. And this comes long before number has been established, okay? So in book 5, we only deal with magnitudes and ratios of magnitudes, and it's all about proportion. In book 6, we deal with similar triangles. Actually, book 6, I believe, should have come before book 5, but because it uses the concept of ratio, I guess Euclid put it after book 5. Not that it was a serious obstacle, because it's very easy to define a ratio as the comparison of 2 magnitudes. And so it was not necessary to have book 6 come after book 5. And then we have book 7, which is continued proportion. And book 8 and 9. Book 7 is not continued proportion. Book 7 is the book on numbers, on theory of, on the establishment of numbers, the abstract unit, number from the abstract unit. Then 8 and 9 are continued proportion, and then we have incommensurable magnitudes in book 10. But since we're quite a way off from that, we'll leave that for the time being. And once we get there, we'll have 3 books left to cover. So I hope you've enjoyed this little presentation, that you'll join me again soon for another one. My name is John Gabriel. This is the New Calculus channel. Till next time, goodbye.